Welcome to Data and Analysis of Statistics, Day 1. So welcome to Data Analysis and Statistics, Day 1. So statistics is the collection and analysis of data. So it happens in our daily lives, whether we know it or not. It happens when talking about diseases, medicine, population, you name it, we can basically find a stat on it. So we can't survey everything in the world, so we take samples of it. Samples are selected members that represent a population. So when talking about an example, we can find that scientists surveyed 1/4 of Chicago to find that an average of 2 children live in each household. My goodness. So our population is the total amount of people that is it affecting and what we're trying to find out. So our population is Chicago residents. And the sample is just the people that we talked to and we sampled or surveyed in this case. So scientists surveyed 1/4 of Chicago. Our sample is 1/4 of Chicago residents. So our sampling of our population gives us an accurate representation of the entire population. So there's 3 different types of ways to collect and analyze data. Analyze. Look at me. This is why I'm a math teacher and not an English teacher. Analyze. So we have surveys. Surveys is collecting data about a population by asking questions. On an individual's behavior or opinion. So I have this little picture or infographic to show that we just take in their opinions and their feedback, and then we reach a conclusion. So an example could be a Twitter poll over favorite TV shows, movies, songs. I think you get the point. It could be even smaller scale. So in a class, we could ask what favorite social media. Or sport or class. So surveys just give us feedback on an individual's opinion and behavior. Now, our second method is an observational study. So an observational study is collecting data through observation. Oh my goodness. Observation. without interfering. The outcomes. So you're just standing back and watching the population. You have no say, no control. So an example could be assessing those who smoke and heart disease. Wow, I cannot spell. Once again, this is why I do math. Okay. So they're not giving them any sort of treatment or medicine. They're not affecting their exercise. They're just simply looking at those who smoke and see if they have heart disease or don't have heart disease. And then our third and final method is an experiment. I know you guys have all done types of experiments in your science classes. So it's collecting data through a controlled study to understand cause. Wow, it's really small. And effect relationships. So it's your cause and effect. If you give something, you want to see how it affects it, whether it's negative or positive. So an example could be, you can think of many examples for experiments, but I'm going to say giving half of students gum to see effects of test taking skills. You could also have an experiment to see if Gatorade enhances athletes' performance, or whether or not serving pizza every day increases the pizza, if kids like pizza more, because they would be having the option of getting the pizza every day. There's many different experiments that you can do and examples. So now, if we scroll on to the next page. When talking about statistics and collecting data, there's this thing called bias, which we're going to talk about just a little later. But in order to prevent bias, we have this randomization. So randomization is when every member has an equal chance to be selected for the sample. So there's no pattern. It's just completely random. Everyone has the same chance, equal chance, no matter what. So now we have to see an example or understand an example for each of our three methods. So randomization in a survey could be employees are chosen for a survey by their names being drawn out of a hat. Now, observational study, if we remember our definition before, it was just you were standing back and watching everyone and assessing their words. Depending on what you're observing, there we go. Depending on what you're observing, depends on what type of data you're going to collect. So in order to implement randomization, you would have to randomly choose the participants to be observed. This kind of correlates with the survey, so you could choose the random participants to be observed by choosing their names out of a hat. And then when talking about randomization in an experiment, it would be randomly assigning treatment to the participants. Notice how each of these have the word random. So there's never a pattern. It's just completely by chance. So now it's important to know that statistics is a non-neutral. So non-neutral is another way to say biased, technically, meaning it is meant to serve an interest. Okay. So bias is having assumptions that may influence the data collected. We all have different opinions, interests. I know many of you guys have TikTok and that thing called the For You page. It's different than your friends. It's different than your parents. If your parents have it, it's different than mine. That's why it's called a For You page. It's meant to serve your interest. So when taking data in for a specific thing, you have to keep in mind the interested individuals and the possible bias it might have. So for this first one, if you're surveying people about the best college basketball team between Indiana University and Purdue University, your interested individuals are going to be people that go to IU or who are fans of IU, Purdue, and basketball lovers. So anyone that's interested or would have a very strong opinion about this topic. So your possible bias that would come from surveying them would be only asking the Purdue, IU students or the basketball lovers. So you'd be getting a very skewed or very biased opinion because it would kind of be like only the IU people would choose IU to be the best and only Purdue people would choose Purdue to be the best. So you wouldn't really be able to get an unbiased or true opinion. Then there's another type of, well, not another type, but another example would be favorite food between pizza and burgers. Your interested individuals are going to be your food critics. Restaurants. Oh boy, the word I just really never can spell right. And there's more examples, but I think you guys get the idea. So your possible bias would be just collecting that data while you're in that specific area. So if you're surveying people that are in a pizza parlor they're most likely going to say pizza's their favorite. Or if you're at a burger restaurant where they're famous for their burgers and you ask them what's their favorite food between pizza and burgers, they're most likely going to say burgers. So you want to take that survey outside and get an unbiased opinion. And our last example that we have is best phone service. So obviously interested individuals are going to be phone companies because that's how they make their money. They want to be the best. They want to get all of the clients from the other people. And then you're going to have your users. I know when I was in high school, we would have a debate of whose phone service was better and who had better service and what location. So a possible bias that you would have would be collecting the data. It's supposed to be an N. The data in / next to that phone service. So if I'm inside AT&T and I'm asking the employees and the future shoppers what their favorite phone service is, they're most likely going to say the place that they're in. Okay. Now, if we have a short discussion over how might randomization of data prevent bias, we talked a lot about it skews one way or the other. So they're extreme on one side whether they like it, or extreme to the other side if they don't like it. So it ensures that each treatment is equally likely to be given. Maybe if I can write. So it gives a true representation of the data collected. All right. And our next lesson is going to be over bivariance and creating tables.